Welcome to the presentation on the number of ways to split an array. Let's dive into how we can solve this problem. Given an integer array called nums, our task is to split the array into two non-empty parts. The goal is to ensure that the sum of elements in the left part is greater than or equal to the sum of elements in the right part. We need to determine how many valid splits are possible. Here is an example to better understand the problem. Given the array nums containing the elements 10, 4, -8, 7, let's check the possible splits. The first split has a left part of 10 and a right part of 4, -8, 7, which is valid. The second split has a left part of 10, 4 and a right part of -8, 7, which is also valid. The third split, however, has a left part of 10, 4, -8 and a right part of 7, which is not valid. So in this case, there are two valid splits. To solve this problem, we follow three main steps. Calculate total sum, iterate and evaluate splits, check conditions. First, compute the sum of all arrays in the array. Then iterate through the array using a running sum for the left part and calculating the sum for the right part dynamically. For each split, check if the sum of the left part is greater than or equal to the sum of the right part. Let's look at the first part of the C++ implementation. Here we include the necessary libraries and define the function ways to split array. First, we initialize total sum to 0 and calculate sum of all elements in the array. In the second part of the code, we initialize a variable left sum to 0 and a counter variable count to track the number of valid splits. Then we loop through the array to calculate the right sum dynamically by subtracting left sum from the total sum. Now inside the loop, we check if left sum is greater than or equal to right sum. If it is, we increment the counter. Finally, after the loop, we return the count of valid splits. Let's break down the code. First, we calculate total sum, which helps us efficiently calculate the sum of the right part. Then we iterate through the array but stop before the last element to ensure both parts are non-empty. The key check is whether left sum is greater than or equal to the right sum, and if it is, we increment our counter. Now let's walk through an example with the array nums containing the elements 10, 4, -8, 7. First, we calculate total sum equals to 13. Then we check each possible split. In split 1, left part is 10, right part is 4, -8, 7, which is valid. In second split, left part is 10, 4, right part is -8, 7, which is also valid. And finally, left part is 10, 4, -8, right part is 7, which is invalid. In this case, we have two valid splits. Let's analyze the time and space complexity of the solution. Time complexity is big O of n, where n is the length of the array. We traverse the array once to calculate the total sum and another time to evaluate the splits. Space complexity is big O of 1, as we are only using a constant amount of extra space. To summarize, the problem asks us to count the valid ways to split the array. The approach involves calculating the total sum and then iterating through the array to evaluate each possible split. The time complexity of the solution is big O of n, and the space complexity is big O of 1.